when I see example 7, first thing that you should notice, I hope, is that there are two different variable types, okay? You can't put cosine 2x together with cosine x. They're not like terms. You have two different angles. One of them could be 50 and the other one would be 100 or whatever, okay? You've got two different angles. One's a double angle. And so I know I can't isolate, and I won't be able to factor either because they're different. So I'm going to have to try and use an identity, but luckily we have an identity. And hopefully you recognize and remember a double angle cosine angle. Cosine 2x has several different options. Cosine 2x, don't write this down, is cosine squared x minus sine squared x, or cosine 2x is equal to 1 minus 2 sine squared x, or cosine 2x is equal to 2 cosine squared x minus 1. We've got three different identities or three different options, and we want to do a substitution. Okay. Now, if you compare the left side to the right side, what I'm going to want to do is use the one with cosine in it. I don't want to introduce an extra sine sine function. I don't want two different functions. I want the same function, and then hopefully I can combine the terms, or maybe I can isolate, or maybe I can factor, or something like that. And so, to me, there's only one option. We know that cosine 2x equals 2 cosine squared x minus 1. And we're going to do a substitution there. So take that, let's take this, and let's plug it in place of cosine 2x there. So just doing that substitution and bringing this part down, I'd have 2 cosine squared x minus 1 equals cosine x. Which is good for us, I suppose. I've got two different cosine functions. I've got a cosine x and I've got a cosine squared x. And so that tells me I won't be able to isolate, but I think I'm going to be able to factor. And so that's what I want to do. Let's subtract this cosine x over so that everything can be on one side. I'd have 2 cosine squared x minus cosine x minus 1 equals 0. This is something that I can factor. Okay. To me, it kind of looks like this problem: 2x squared minus x minus 1 equals 0. Maybe that looks better to you or easier to handle. You don't necessarily need to write that down, but that's what it looks like to me. And when I factor this, I know there's a 2x and an x, and I need two numbers that multiply to -1, and then they're going to produce that -1. I can factor this. Remember, to do that, you think about FOIL. Whatever goes over here needs to be multiplied by the 2, and whatever goes here isn't multiplied by the 2. But you factor that, and then you can see that x is going to equal -1/2 or +1. If you don't know how to factor that, you can always use quadratic formula. Okay? So I'm going to factor. Maybe you want to use quadratic formula. It doesn't really matter. But we're shooting for that -1/2 and that 1. That's what's going to happen. When I factor this trig function, I'm going to have 2 cosine x plus 1, and then cosine x minus 1. The cosine x in this problem kind of acts like the variable did of my other one over there in green. So splitting it up, 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. I'm subtracting 1 and dividing by 2. There's my -1/2. I'm adding 1, and there's my 1. I still have that -1/2 and that 1, but those are equal to cosine x, and I'm still going to have to do that inverse cosine in order to isolate. So do your inverse cosine, and notice we are in radians here, okay? And use a chart backwards. Inverse cosine of 1/2 is going to give me a pi/3 reference where cosine is negative. And so if you think about that, pi/3 where we're negative is on that left side. We get a common denominator here. We call this pi, but we call it 3pi/3. And so I can see this one will be right before that. It's 2pi/3. And then this one is right after 3pi/3. So 4pi. We've got a couple of my answers. Okay. Now, I don't know if you noticed, but as soon as we got to this step here, we no longer had a double angle, so we're not going to have to worry about doubling that interval. Okay, as long as we're just solving for x and don't have any 2x anymore, we got rid of that double angle. So when we got rid of that double angle, we didn't have to do a double interval. So my 2 pi over 3 and my 4 pi over 3, they're good. So then we look at the other one, look at cosine x equals 1. Sometimes students have a hard time with the 1s and the 0s. I would encourage you to look at the unit circle. We know the ordered pairs of certain points without having to think too hard. But the cosine x equals 1 means where is the x coordinate equal to 1, and it's only right there. And so cosine x equals 1 is going to give away an angle of just 0. And so I can see that x equals 0 again. And so I have 3 answers. I've got 3 answers. They are 0, 2 pi over 3, and 4 pi over 3.